In this video, we're going to solve a couple of systems of equations. So there's lots of ways to solve systems of equations. In my mind, the easiest thing to do if you have a graphing calculator is to use matrices. Even with using matrices, there's about 3 different ways you could use them. My favorite is called reduced row echelon form. I'll show you what I mean. Here I have a system of 2 equations with 2 variables. We're going to solve this system. Now again, you could solve with substitution, elimination, graphing, lots of stuff, but I'm going to show you a little trick that you can do on your calculator by making use of matrices. So what I'm going to do is I'm going to go to my matrix menu and I'm going to edit a matrix. Now this matrix is going to be comprised of the numbers in this system of equation. Now there's 2 equations, so I'm going to go with 2 rows for my matrix. And there's 3 columns as you look at it. There's x's, there's y's, and there's constants. So I'm going to go with a 2 by 3 matrix. I enter in the numbers that I see, not worrying about x or y, but I do keep this constant over here. So the first row of my matrix will be 2, -4, and +16. And row 2 of my matrix is going to be -3, +1, and -26. Now, once I have my matrix made up, I'll quit just to go to the main screen. What we're going to do is we're going to do a little matrix math. So we go to Matrix, Math menu, and I got to go find something called RREF, which stands for Reduced Row Echelon Form. If you want to learn how it works, why it works, take linear algebra in college. For now, just trust it because it works really well. RREF, here we go. So I choose that operator. I'm going to find the reduced row echelon form of matrix, whichever one I edit it. Well, that's matrix A. So put matrix A into reduced row echelon form. Bingo, there it is. So I've got 108.8 and 01.4. Okay. Now here's what that means. And maybe if you don't like decimals, we can always change those into fractions. Fractions are required for the answer. So if I drag this over here, here's what this means for us. This means that when I've got the 1s on the diagonal, that means when x is a 1 and y is nothing, x would be equal to 8.8, and y1 is equal to 0.4. So the solution of this system of equations would be 8.8.4, or 44/5 and 2/5. Now, to solve a system of 2 equations, you can do that by hand, it's not that bad, but if I'm going to do a system of 3 equations, I would definitely use my calculator. So let me show you how to do that one. So here we go. I start by typing in a matrix. So this time, because there's 3 equations, the matrix that I use is going to be 3 by 4. Okay, 3 rows, 3 equations. So 7, -10, and 8. Now, if you were missing a term, if there was like no z term here, then I'd have a 0 there to hold its place within my matrix. Okay, just as an FYI. And -50. Next row is -2, -5, +12, -90. And the next one we've got 3, 4, 4, 26. Got all my numbers entered. Again, you just got to be careful, make sure they're all entered in correctly. I'm rushing just to get it done, but this looks pretty good. Let's then put this guy into reduced row echelon form. Sometimes hitting the up arrow will get you there a little bit faster. So RREF of matrix A, my 3 by 4 matrix. I hit enter, spits out my answer. So 6, 6, 4. So 6 is the value of x, 6 is the value of y, -4 is the value of z. If you want to check that out and plug all 3 of those numbers into all 3 equations, it will work out. So that's a pretty cool way to solve systems of equations by using matrices.